Hey, this is Mr. String going over the Precalculus number 13, quiz number 13, sections chapter 4.4 to 4.5, basically graphing all 6 trig functions, taken on March 27, 2019. This is version A. For matching, you're asked to graph these, and I left a clue there. Hopefully you picked up on this clue that if the graph finishes by 3 pi, cosine, its period ends by, his equation is 2 pi over b, and if your b value, you're trying to figure out the b value, so let's just say you're doing this by hand, and you know the graph finishes by 3 pi, then what you can do is you can just cross multiply, and you'll get 3 pi b equals 2 pi, and if you divide both sides by 3 pi, you'll get b to be 2/3. So in this problem, I know that I have cosine. Remember, cosine starts at like a value like 1 or 2 or whatever its amplitude is, and it finishes at that value as well. And my little trick is you turn it sideways, and it's a sideways C for cosine. So I know this graph is cosine. I know that b value is 2/3. The only one that has that right here is this equation, so D is the second one. Over here I also have cosine. This one ends by 2 pi, so your b value is going to be just 1. So b is equal to 1 in this problem. And then notice my amplitude here. So my amplitude is going to be 3. So cosine with an amplitude of 3. This is the only one right here, which is b. This graph finishes by pi, and this is sine, so sine is 2 pi over b, and if it finishes by pi, then you can do cross multiplying. You're going to get 2 pi equals b times pi, and if I divide by pi on both sides, I get b equals 2. So this graph is sine, and my b value is 2, so that means it goes right there. So I have sine of 2x, and that would be this one right here. That would be choice A. So I have this one, I have this one, this one. Here is another sine. This one ends by 2/3, 2 pi over 3. So if you want to, you can figure it out. I already know the last choice here is C, but I just want to prove to you sine is 2 pi over b, and then it finishes by 2 pi over 3. So you'll just see that, well, the numerators are the same, therefore the denominator b is equal to 3 in this problem, and you have sine. So the only choice that you have there is C, and then also your amplitude or your maximum is 4. So those were 1 point apiece. Question number 2. Which function has the same period as y equals 4 cosine 2x? Well, I wrote my letters above it, a cosine bx, and so that my a value is 4, my cosine, or my b value is 2. So cosine, its period is 2 pi over b, so my b value there is 2, so 2 pi over 2, and then cancel there. So basically I'm trying to find one that also has pi as its period. Well, if you pay attention here, tangent has a period or equation of pi over b. Sine and cosine is 2 pi over b. So there's a big idea. And here, my b value is 1, right next to the x. So that means this would be pi. So this is going to be your answer. Over here, your b value, if you need to, always write the letters above. That might help you. B value is 2. So this one is pi over 2, so no, that's not the answer. And then over here, my b value, a sine bx. My b value is 1, so 2 pi over 1 just gives you 2 pi, and that does not match pi that we need. And the last one, same thing, a cosine bx. So my b value is 1, and then you just have 2 pi. Again, we're trying to look for one that has pi, and this is only 1, so your answer is choice 3. Question number 5. 3. Why did I say 5? The phase shift of the graph is, so phase shift is just equal to the C letter. It says, this one's kind of hard to read, y, let me rewrite it, y equals sine x plus pi over 2. There it is. And remember, the equation must have a minus sign. So if you see a plus, you can change it to a minus. This is a minus sign right there. So sine of x minus negative c, because the opposite of negative c is a plus sign. That means if you have x, then you have this minus sign, then our the opposite, and then our c value, which is pi over 2. So if you put everything, you have the x, you have the minus, that means our c value, in this case, would be negative pi over 2. Sorry, that's not a minus sign. So the formula has just x minus c. So there must be a minus sign. There's my minus sign. Therefore, c is equal to negative pi over 2. Negative in the c value basically means you're going left. That would be choice D. Now, I do have a silly phrase, add to x, go west or left. So adding to x, there's adding to x. This basically means you're going to have a shift going left or west. That's the word left. Okay? That would be choice D is your answer. Question number 4. Each tick mark on the x-axis represents pi over 2. Pi over 2, pi, 3 pi over 2, 2 pi. Which function below has this graph? So it says it has this graph here. And you should recognize, okay, number 1, it's not cotangent. Cotangent is the snake, the reverse snake. Okay, there's cotangent. That's what cotangent looks like. Okay, what's the difference between secant and cosecant? Cosecant's reciprocal is sine. And remember, your graph for sine is going to look something like this. Kind of small, but just give you an idea. And basically, the graphs of those are just the bumps on top. So in green, it would be my final answer. Now, if you notice something, that this one here, though, doesn't cross the y-axis. There's an asymptote there. Okay, so you'll notice that this graph here does cross the y-axis. So if you graph out cosine, cosine looks like this. Okay, and then if you draw the bumps above it, your graph's going to look something like this. And she'll go like that. Okay, so which graph has that? Well, that looks like this graph right here. And you can kind of see that because what I did here in pink magenta is what I did there is I graphed cosine. And then after you graph cosine, one method is just drawing the bumps above it. So the reciprocal of cosine is secant, so your letter choice is A. That side was worth 12 points. Let's go to the back side. All right, here. Graph the following trig function, y equals cotangent pi x. Step number 1, I asked you to identify the A, B, C's, and D's. So if you write the letters above there, you'll recognize that the A value here is 1, your B value is pi, and C and D there is none, or you could have written something like none or no or 0. Remember, how do you know there's a C value? There's a set of parentheses over here, and you'll see a plus or minus in there. The D value has something like plus something and or 3 minus or 3 plus, so there is none. So if you got all those correct, I gave you a check, which gave you the 1 point. Find the period. Okay, here's a common mistake for students. Remember, tangent and cotangent have a period of pi over b, not 2 pi over b. Well, in this problem, I know that my b value is pi. Put it there. Something over itself cancels. In the sense, canceling equals 1 in this problem. So your period is 1. Okay, here. So if you got that correct, I usually put a check above that, or I might have put an X there. Okay. The next part is creating a table of values. Well, basically, you take this and you divide it by 5. You should have 5 points. So what I like to do is I just draw 0 and 1. And then I say, what's the midpoint between 0 and 1? So you can just add those, 0 plus 1 divided by 2, and that gives you 1/2. And you do the same thing this direction. You can do it out of 4s. So 2 over 4 plus 4 over 4 gives you 6 over 4, and 6 over 4 divided by 2, or 6 divided by 2 gives you 3, so 3/4. And same thing between 0 and 1/2. 0 plus 1 is 1, and 1 divided by 2 is 2. 1 divided by 2 is 1/2, so 1/2 of over 2 is 1/4. And you think about it like a dollar bill, right? You have 1 quarter, 2 quarter, 3 quarter, 4 quarter. So those are my 5 points. You should have 5 points there. Okay? And then what do you do with these x points? Okay? Here you're using the order of operations, or another way of thinking about it is if you move the d value way over here, all you're doing is you're moving in this direction, right to left. You basically take our x value, these are our 5 x points, you take 0 there, so you're doing pi times 0, so that's what I'm showing here. This is multiplying by pi. So pi times 0 gives you 0. Pi times 1/4 is pi over 4. Pi times 1/2 is 1 pi over 2, or pi over 2. If you multiply by pi here, this becomes 3 pi over 4, and multiply by pi here, you get pi. So you've done these two parts right here, and now you're going to do cotangent at those values. Okay, so cotangent at 0. Cotangent is x over y. So that would be 1 over 0. 1 divided by 0 is undefined. Cotangent at pi over 4, it's this second notch in the middle there. And the second notch has an order pair of radical 2 over 2, comma, radical 2 over 2. And so cotangent is the x over the y. And my trick is just to look at the, cover up the 2's there. And so it's just radical 2 over 2, which is 1. And then cotangent at pi over 2, the order pair is 0, 1. And then y divided by x is undefined. Take that back. X divided by y, 0 divided by 1 is 0. 3/4 pi. Cotangent is negative in quadrant 2, so the order pair in this middle notch is a negative radical 2 over 2, comma, radical 2 over 2. So an x of negative radical 2 over radical 2, that'll give you a negative 1. And then cotangent at pi, your order pair is negative 1, 0, so negative 1 divided by 0 gives you undefined. Well, how do you graph this? Incorrectly graphed pink. If you take your order pairs, so essentially at 0, you have undefined, which is a vertical asymptote. And then at 1/4, your answer is 1. So 1/4, you go to 1. And at 1/2, you have 0. 1/2, x value, y value 0. X value of 3/4, you go to negative 1. And then at 1, your graph is undefined. And then cotangent is a snake. And this is a good hint for cotangent and tangent. They make this linear equation through these 3 points. Okay? Pink was incorrect. So shape, did you know that cotangent starts on the left and ends on the right? Accuracy was kind of like generally looking at your graph, and then the x-intercepts was this correct. So I made the graphing trig equations out of 6 points, and it's possible you got a 0 even though you attempted it. Question number 9, and I believe this question was from your previous quizzes, which you guys got as worksheets. Question number 9. 2 ways to do this problem. I'll show you the second way at the end about just graphing the points or the table of values. So I definitely want to show you an alternative just in case you're not getting it. All right, the first thing you want to do is you have y equals 3 minus 6 cosecant 2 parentheses 2x plus pi over 2. And if you get these letters here, our letters are D, A, B, C's inside. Now, notice how I moved the D value to the far left. So this here says you have to take a greatest common factor. You have to take a greatest common factor. Why? Because you have a 2 in front of the x, and there's no letter in front of the x here. So if you factor out a 2, you're going to get, let's hear, 2 times x minus a box. So this is what I like to do if you can't figure out what the c value was. So the box is 2 times the box is going to equal, put a plus sign there if you wanted to, but is pi over 2. So 2 times the box is pi over 2. So I'm trying to help you figure out how to factor here. Now, dividing by 2 is the same thing as multiplying by 1/2. Dividing by 2, so normally you would have put the 2 here, is the same thing as multiplying by 1/2. It's just the 2 is on the bottom. What happens there is these 2's will cancel, and over here you get box equals pi over 4. So, scribbled out, that is pi over 4. Now, this has a plus sign, and remember your formula has to have minus c, so I changed the plus sign to a minus pi over 4. This helps you identify that your c value is negative pi over 4. C value is negative pi over 4. So that was the first step, is your a value. A value is negative 6 here. Here I accepted the absolute value is the amplitude. I just want you to be able to identify letters and then use them. So I didn't ask you for the amplitude, but a value is negative 6. The temptation for a lot of students is they added or subtracted those. 3 minus 6, that would have been incorrect. Remember, your b value is 2 here from factoring. And your d value is the one that it's not attached to the trig function by multiplication. It's usually over here on the end or here in front. The next thing you need to do is find the period. So cosecant, its reciprocal is sine, and basically all 4 trig functions of the 6, besides tangent and cotangent, are 2 pi over b. Our b value is 2, so if you put in 2 there, your 2's will cancel and you're left with pi. Okay, now, in this problem, you cannot take your 5 points from 0 to pi. And the reason why you can't is because in this problem you have parentheses. And the parentheses basically tell you there's a phase shift. It's moving left or right. You already kind of knew that. You know the graph's going to eventually move left pi over 4. And you can actually see that in my finished graph. It's pushed off there. So what do? You basically take everything to the right of the trig function, that parentheses or whatever you have there. I chose to use my factored form. Let me show you my factored form. Let me show you the other one as well. So here, I'm just trying to solve for x. Solving for x is a reverse of PEMDAS, so I'm going to divide it by 2 on both sides. This means my 2's will cancel. 0 divided by 2 is 0. 2 pi divided by 2 is just pi. If subtract pi over 4, pi is essentially pi over 1, or multiplied by 4 over 4. You get 4 pi over 4 minus 1 pi over 4. You get 3 pi over 4. And 0 minus pi over 4, you get negative pi over 4. That basically means I'm starting at negative pi over 4 and ending at 3 pi over 4. If you did it the other way, I have space up here. Let me see if I can show you that to you really quickly. 0, 2x plus pi over 2. Students were doing a lot of crazy math here. For example, a lot of students were like dividing by 2 at first, and that would be incorrect. The reason why, again, you simplify this direction, but you solve in this direction, which means that you're not allowed to divide by 2. Now, if you did that, it would be pretty complicated. You would have to divide by 2 on the whole expression, which means 2x divided by 2 and pi over 2 divided by 2. So the proper way, or using our order of operations, I would just subtract pi over 2. This is 2 over 1, or it's essentially 4 pi over 2. And you would get negative pi over 2, 2x, and then 4 minus 1 gives you 3 pi over 2. And then over here, I could divide it by 2. Remember, dividing by 2 is the same thing as multiplying by 1/2. So essentially, you'll get negative pi over 4, which we got below. And over here, this would become 3 pi over 4. All right, I'm going to show you guys my crazy table, and then I'll show you, we'll graph it, and then I'll show you a variation. Sufficient work might be easier for you. You get to kind of pick. Okay, so I go from negative pi over 4 to 3 pi over 4. And again, you're taking the midpoint between these two. So negative 1 plus 3 is 2, and 2 divided by 2 is 1, so 1 pi over 4. So the reason why you know that works because the distance between here and here is 2. And the difference between here, 1 and negative 1 is 2. Well, what's in between here? Then you'll realize that you're just counting by pi's over 4. Negative pi over 4, you add 1, that's 0 pi over 4, 0 plus 1 is 1, 1 plus 2 is 2, 2 plus 3. So there's my 5x values. The next thing I did was you take your x values and then you're going to, so for example, negative pi over 4, and then I put it into my, which one did I choose? I chose to add pi over 4 first. So essentially when you pick, it doesn't matter, but I chose to pick this equation first. Okay? So what I did is I added pi over 4 to each of these. So if I add 1 pi over 4 to negative 1, that gives you 0. That gives you 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, which is 1. And then again, you're doing order of operations. So I'm doing parentheses, and now I'm doing the multiplication tables times 2. So I'm taking all this whole row, basically multiplying it by 2. 2 times 0 is 0. 2 times pi over 4, remember that's like 2 over 1, so that's 2 pi over 4, which is pi over 2. 2 times pi over 2, which is 2 pi over 2, which is just 1 pi. 2 times 3 pi over 4 is 6 pi over 4, which reduces to 3 pi over 2. And this becomes just 2 pi. And then, remember, the reciprocal of cosecant is sine. I saw a lot of students, even I made a mistake right there. When I recognize myself, it is sine. So what you're doing is now you've changed, we've talked about changing cosecant into sine. So now you have your golden row for sine. And that should just be 0, 1, 0, negative 1, and 0, right? You're just going around the unit circle, and then you're looking at your y value. So 0, 1, 0, negative 1, 0. Okay, what do you do next? Well, we did sine, and now here, pay attention, you are multiplying by negative 6. So multiply this whole row by negative 6. Okay, that what happens is your a value, because it's negative, it's basically flipping the graph over the x-axis. And this is a tricky part at the end. You are essentially adding 3 to each of these. So 3 plus 0 is 3, 3 plus negative 6 is negative 3, 3 plus 0 is 3, 3 plus 6 is 9, 3 plus 0 is 3. So in blue, I'm going to graph these points. At negative pi over 4, I'm going to graph 3. Negative pi over 4, 3. At 0, I'm graphing negative 3. That shows the shift down. Essentially, sorry, up. And at pi over 4, you have 3. And then you have, at pi over 2, you have 9. And at 3 pi over 4, you have 3. Remember a couple of hints. This is your midline, and the midline is your d value. Another couple of hints or common mistakes is then students try to do something like cosecant. If you're using this method, which I've taught you, now you're supposed to erase. Draw the bumps and then erase. So you see our bump here. You can draw another bump. And at the x values, the old x-intercepts on this midline, this is where you're drawing your asymptotes. Okay? This is method 1 for using the table of values. Now, let me show you an alternative, and a couple of students are using this, and it's totally fine, and I want to show you how it works. Okay? So this method says you notice in this table here you don't have cosecant, you just have sine. You're graphing sine, and then you're drawing what's above and below it. Now, if you choose to use a table of values for cosecant, let me show you how this works. You still have to have these 5 points, and I just copied them here in the table of values. And what I did is I take pi over 4, and it might just easiest if I change this back for right now. If you take negative pi over 4 and you put into your x value, you're basically doing the order of operations through all of this, and what is your output, okay? So negative pi over 4 plus pi over 4 is 0. 0 times 2 is 0. Cosecant at 0. Cosecant is r over y. 1 divided by 0 is undefined. So you can stop right there. Undefined, I don't need to multiply by negative 6. It's still undefined. And then add 3, it's still undefined. So undefined. Negative pi over 4, undefined. At 0. Remember, you can use either of these equations. I just chose to use this middle one. Let me show you how it even works in this one. 2 times 0 is 0. 0 plus pi over 2 is pi over 2. Cosecant at pi over 2. That would be y over r. That would be 1. So 1 times negative 6 is negative 6. Negative 6 plus 3 gives you a negative 3. Pi over 4. 2 times pi over 4 gives me pi over 2. Pi over 2 plus pi over 2 is just 2 pi over 2, which is just pi. So cosecant at pi, r over y is undefined. Undefined times negative 6 is still undefined. Undefined plus 3 is still undefined, and that would be right here. And then 3 pi over 4, again, you could choose either of these equations. Let's go back to the first one just to show you something different. 3 pi over 4 plus 1 pi over 4 is 4 pi over 4, which is pi. 2 times pi is 2 pi. Cosecant at 2 pi is r over y, which is undefined. And you can just graph that right there. So in some ways, you're kind of using more mental math. Again, 1 point for all the correct letters, 1 point for the correct period, 1 point for either this correct table or this correct table over here. On the graph, I was looking for the basic shape of cosecant, where the bumps are drawn, and then its accuracy, making sure you have the y-axis and x-axis, and the x-intercepts are these values. That side was 12, so 12 plus 12 gives you a total of 24. Hopefully that was helpful for you to understand how to graph trig functions.